So now let's spend some time to understand the application of conservation of mechanical energy theorem in this question. Going to the given conditions, mass is zero point 0.1 kilogram, height is 10 meter, the initial height at which it is dropped. It rebounds to a height of 5 meter, and we've been asked to find out the impulse of the force imparted by the ground. To look at the keywords given in the question, the first one would be the phrase spherical body, which actually means a ball like object and nothing relevant to the dynamics here. It is dropped from a height of 10 meter. Dropped, it actually means that the ball is simply released. Therefore, the initial velocity of this ball is equal to 0. Gravity pulls it down, so it speeds up as it falls, which means this movement is only under the influence of gravity till it hits the ground, right? Once it hits the ground, it rebounds to a height of 5 meter, which means the direction of motion reverses here. After hitting the ground, it rebounds to a height of 5 meter, right? So the initial height was 10 meter, drop down, hit the floor, rebound to height of 5 meter. Now, what is conservation of mechanical energy? In the absence of non-conservative forces like friction or air drag, the total mechanical energy of the system remains constant, which gives us that the initial mechanical energy will be equal to the final mechanical energy. So, initial position, initial mechanical energy, the final position corresponding to final mechanical energy. In other words, if an object falls when it is dropped, the potential energy here, all of this is stored to the kinetic energy. The other way around, during the rebound motion, what happens is when the ball is rising up, all the kinetic energy here is converted to the stored up form of potential energy. Okay. Now we'll have to apply conservation of mechanical energy in both directions. When I say both, I mean first from the falling side, which means falling from 10 meter before hitting the ground, and the second it's from rising from the ground to the rebound height of 5 meter. Then we'll calculate the velocity in these two cases and then find out the impulse, which is change in momentum, which is mass into final velocity after impact minus initial velocity, which is before impact. Okay. Well, I do understand that things are getting a bit more complex here, right? And if you haven't written down any notes along with me, I would say you can feel free to just go through this, go through the solution. Don't spend time writing down things. We will discuss what has to be written down in the next part of the solution. Okay. As of now, just focus on what has been, what has been shown here. Don't worry at all. Yes, you might have only around 75 to 85% of clarity in this concept here. Once we write it down, once we calculate these things using a pen and paper, things will start making more sense. Okay, right. Applying conservation of mechanical energy for the downward motion at the top, which means before the fall here, potential energy is mgh1, where h1 is 10 meter. We know how. Kinetic energy is 0. Why? Because velocity is 0, and therefore kinetic energy is also going to be equal to 0 because it is dropped. Just before the impact, which means it has not yet met the floor, potential energy very close to the ground is nearly equal to 0. Why? Because the reference height. All energy therefore becomes kinetic, which is equal to 9.8 joules. So while falling, we have two energy levels: potential energy initial, which is equal to mgh1, kinetic energy initial, which is equal to 0, potential energy final just before the impact is 0 because the body is near the ground. Yes, now you're wondering how is it potential energy is 0, right? So that's where we plug in the concept of reference level for the calculation of potential energy, which is something we shall discuss later. Okay, while we do the written part. Okay, right. Now, initial mechanical energy is equal to final mechanical energy, which means before the impact should be equal to after the impact. And potential energy initial plus KE initial should therefore be equal to KE final plus PE final, which gives us mgh1 plus 0 is equal to 0 plus half mv square, or doing the rest of the maths, which gives us that velocity 1 is equal to 14 meter per second. Right? Okay. Now, to find out impulse, we need mass into velocity final minus velocity initial. So far, we have discussed the derivation of velocity initial, which is 14 meter per second. Now we'll have to find out velocity final. And the velocity initial here is minus 14 meter per second because we are taking it along with the direction which is acting downwards. Things that should have been very clear to you if you followed the discussion on solving the same question using what? Using exactly work energy theorem. Then we have conservation of mechanical energy while the ball is in the rebound motion. So just after the impact, which is again near to the ground, potential energy here is almost equal to zero, right? Kinetic energy is half mv2 square. Why is it v2? Because the object was coming down with some velocity v1. It has hit the ground and then it is going up with some other velocity v2. Why? Because some of the energy is lost in this process. Therefore, half mv1 square will not be the same as half mv2 square here. Why? Because some energy, the difference between this is lost here. Okay. So yes, that's one thing I wanted to say. Don't worry, I do understand that we are still thinking of it. Well, why is some energy lost and things like that? We need some more time and patience, of course, to understand that as well. Okay. Now, during the rebound, when the height is 5 meter, which actually means that the ball is now at the top of the rebound motion, the kinetic energy is equal to zero. Why? Come on, the velocity is equal to zero. Again, why? Because the ball is momentarily at rest at the maximum height. And therefore, potential energy here will be equal to mgh2, where h2 is 5, and kinetic energy will be equal to 0. Right? So we have two values, potential energy, kinetic energy, before impact and at the maximum height. Now, if we are to apply conservation of mechanical energy, initial mechanical energy should be equal to the final. What is mechanical energy initial? PE initial plus KE initial. Mechanical energy final is PE final plus KE final, which gives us potential energy initial, which is 0, KE initial, which is half mv2 square, potential energy final, which is mgh2, and KE final, which is 0. Doing the maths, which gives us v2 is equal to 9.9 meter per second. Okay. Now, using impulse momentum theorem, we have impulse is equal to v final minus v initial. We have now found out that v final, which is v2, is 9.9 meter per second acting upwards. Therefore, the value plus. So we have v final. We initially had v initial. Now we apply 9.9 minus 14, which gives us 9.9 plus 14, 23.9. And therefore, the value of impulse being multiplied by m as 2.39 kilogram meter per second. Okay. Now, so far, we have discussed the solution to this problem here. We were talking about three different things, which is exactly number one, which was okay. Let's just have a quick recap in that aspect as well. So there is something else that I want to share here, which will be regarding Yeah, regarding this point here, why is energy not conserved during the exact process of collision? We will discuss that in detail. I do expect a very, I do consider this as a very strong candidate for a future assertion recent type question when it comes to the chapter work energy power, which is, of course, not the one that we are discussing here, but it will interlink concepts. And come on, we are preparing for the JE mains. You don't do questions chapter wise, you do questions concept wise. Okay, right. So we'll now look for the method 4, which is using coefficient of restitution. So we did start solving the question using equations of motion. Then we solved it using work energy theorem. We used two solutions, one, the concept, and second, the actual numerical solution. Now we are in law of conservation of mechanical energy. And what we will do is we'll also try to solve the using the written part. And then after that, we will start solving this using coefficient of restitution. Okay, right.